In this video, we're going to explain dependency injection from the ground up. I'll also explain why we use dependency injection, and I'll give you an example of how it works. We'll also cover the broader concept known as inversion of control. Dependency injection literally means injecting dependencies. So let us set aside the injection part for now and just look at what a dependency is. A dependency is a part of your application that contains functionality that is needed for another part of your application to function. So if you think of a car, well, a car has a dependency of an engine. You can change which engine you put in the car, but you need to put something in there for it to be able to move. And in a nutshell, dependency injection is the process of choosing an engine and putting it in the car. Here's an example of how this relates to some code. Imagine you have some code here that wants to send an email. So you have a class and a function on that class, and in this function you want to send someone an email based on these arguments. Now, by far the easiest and most popular way to send an email from your code is to use something called a transactional email service. So that's a service that exposes an API that you can call. You send it what you want in your email, and they'll turn that into an email and send it off on your behalf. It's called transactional because this process of you sending them some contents of an email and them turning it into an email and sending it off is one transaction. So this is different to like a marketing email campaign service like MailChimp basically. Anyway, so here's some logos of some transactional email services, and these all work pretty much the same way. You sign up to one of these, you get an API key, and then they will typically have an API client or an SDK that you can download and you can use it in your code. So looping back, we've got your function and we want to send an email using one of these email services. Well, what we do is we pick a service, so let's say SendGrid, and then we import their API client and we use it in the code like this. This example is C#, but the concepts here are the same in Java or any other language that commonly uses dependency injection pattern. Now this will work and it will send an email using SendGrid, but it might not be ideal that you've tightly coupled your code here to this SendGrid client. The bit of code that sends the email is the same as the bit of code that's choosing and setting up the SendGrid client. So sending the email is strongly coupled to choosing which client to use. Now let's say we aren't happy with that strongly coupling, right? And this is a business decision because you don't want to, if you just want to get this code out the door as quickly as possible, then just leave it like this, right? There's nothing wrong with just doing this and sending an email. You don't need to over-engineer everything. However, it might be that your business needs dictate that they might not always want this code to call off to SendGrid. So maybe they want to be able to change their mind easily in the future and they want to be able to use a different email service. Or maybe you want to ship a higher quality product and they've dictated that this kind of code needs unit tests. Well, to unit test this, you really want to be able to call this function without it actually sending an email. Ideally, and that's not possible the way it is now. So we make that decision that we want this code to be a bit more flexible. Then you might decide to do some extra work here and add in an abstraction. An abstraction is something that looks like something else, but it isn't exactly something else. So it's a simpler version of it, basically. We can create an abstraction around all of these different email services, because if you remember, they all do basically the same thing. You make an API call to them, and they turn that into an email. In this case, our abstraction can be an interface. We create an interface between our code here and all of these email services, and they reference each other through this interface. I'm going to call this interface iEmailProvider, and I'm going to give it one function called sendEmail. Now what we do is we implement this interface for some of these transactional provider services. So maybe we have a SendGrid email provider and also an AWS email provider and a Mailgun email provider as well. Now these classes all implement this iEmailProvider interface, but they use different code to call off to their own relevant APIs. So back in our original class, we can create a local field or property and make that of type iEmailProvider. And then in our function, we call emailProvider.sendEmail. So this here, this field, this is our dependency, right? Because in order for this function to be able to work, it needs an instance of one of these classes to be assigned to this field. The field can't just be null or it won't compile. You need to put something in there. And this is our engine, essentially. Imagine this class as the car, and this field is our engine. We need to put something in there because it's now a dependency. So hopefully you can see that dependency injection is going to be the process of putting this email provider into this field. But you don't have to use dependency injection just because you have a dependency. So let's first look at how we can do this without using dependency injection. Here, we just create a new instance of the SendGrid email provider when the class is instantiated. Now this will work, and it's not actually that much different to how it was working before, really. The class is still strongly coupled to which email provider it uses, but at least it has an object in this dependency field now, so you can compile it and you can run it. But yeah, this is not an example of dependency injection. This is just having a dependency and using it. Dependency injection for this class might look like this. Here we have a constructor that takes in an instance of the email provider type. So if we wanted to create a new instance of this class, we have to pass an email provider through to it. You can't just put null in there or just skip this argument, you have to supply it. Now so far we've only been looking at the code for this one class, but next we need to jump up a level and look at the code that's using this class. So this is C# code. So in C# we might have a program.cs file that's the entry point into our application. And this will be the equivalent to like a static main method in Java or the main.go in the Go programming language, right? It's the procedural logic that uses our class and it calls this method. Because we set up our class to require this dependency to be injected, then the calling code has to pass it in. So let's say we create a new instance of the myClass class and we pass in a new instance of the SendGrid email provider. Now what we've done here is we've achieved something called inversion of control, because the parent code calls down to the child code, but when it comes to controlling which email service to use, the child code doesn't actually control that anymore. It's this parent code right here that controls which email provider we'll use. So we've inverted the control of whether we use SendGrid or whether we use Mailgun from that child class and moved that up into the parent class. And this really is the end game of dependency injection. We need to be able to move these high-level configuration type things out of the individual pieces of code that use them. And we move them into some kind of high-level configuration. Now this video wouldn't be complete if we didn't talk a little bit about dependency injection containers. You see here how our parent code is creating a new instance of the class and passing a new instance of the email provider into it. Well, if you have lots of classes and lots of these dependencies, then this can get a bit too much doing all these new statements. And also, what if you wanted to pass this same email provider to two different classes? Then you'd need to store it in a variable somewhere and then pass that down to both classes like this. And this is essentially what a dependency injection container is. A dependency injection container is like a storage bucket for all of these dependency objects. So you say to your container, if a class needs email provider, then use this SendGrid email provider. You have this configuration step at the very start of your code's execution that sets up the dependency injection container. And it gives it all of these object instances, or it tells them how to create those instances. And then when you come to create an instance of your class, well, you can just say create a new instance of this class and get whatever I configured the email provider to be. And this is what's called the service locator pattern. And this pattern is what you'll grow familiar with when it comes to using dependency injection, because you'll typically be using a dependency injection container. Now, one more thing. In this example, we've said it's useful because it lets you swap out one email service from another, if you remember our list of email services, right? Well, that's a good use of dependency injection, but it's not the most common benefit. The most common thing that people use dependency injection for is not to swap out this SendGrid email provider for a different email service, but to swap it out for a mock. Now, a mock is an object that implements the email provider interface, but it doesn't actually contain any real functionality. It just does things like logging the calls that are made to it and things like that. And why might we want to swap out these things for mocks? Well, the answer is obviously for unit testing. You see, if we reconfigure our dependency injection container to use mocks for these dependencies, then we can execute our email sending code from a unit test, and then we can inspect the mock to see if the correct calls were made to our interface. So we've managed to write a unit test for our code that verifies that this functionality was correct without actually sending an email. So that's good because it means you can run the same unit test over and over again and not actually send out emails, which is quite useful. Day to day, this is the most common use of dependency injection. To mock out your services and to make your business logic, that's the code that's most critical to the operation of your business, whatever that may be. Well, dependency injection makes it possible to easily write unit tests for just that logic, prove that logic works, and guard it against errors in the future. So I hope that's cleared up some things around dependency injection. For explanations of other concepts across the whole spectrum of software engineering, then please check out my other videos, subscribe to my channel, and if you have any questions about anything that we've covered here, then please put them in the comment section below. I'm James Charlesworth. Why not check out some of my other videos, and I'll see you in the next one.